Welcome to our webinar From PDFs to Precision, Powering Smart Data. Today we'll explore how smart data extraction is transforming document processing and unlocking new possibilities for automation and AI. I'm John Chow, Product Manager at Apryse. Let's dive into how we're helping organizations turn unstructured PDF documents into clean, structured data ready for action. There are over 2.5 trillion PDFs in circulation today, and most of them unusable as a data source. These documents hold valuable data, but accessing it remains a major challenge. In fact, 80% of enterprise data is unstructured, and much of it lives in documents like contracts, claims, forms, and reports. This makes it difficult to extract insights or automate workflows. Apryse Smart Data Extraction is a valuable tool to unlocking this wealth of information. Before we can automate workflows or generate insights, we need clean, structured data. Smart data extraction is the missing layer between raw PDF documents and actionable information. Without it, transformation initiatives often fall short. PDFs are inherently unstructured. They were designed for presentation, not data analysis. That means the content, whether it's tables, headlines, or form fields, is visually arranged but lacks semantic meaning. Extraction tools often produce a raw data dump with no understanding of layout or context. With millions of unique document formats, it's difficult to automate extraction reliably without extensive manual review or custom templates. And when accuracy matters, those errors can be costly. Let's take a quick look at how data extraction has evolved. From manual OCR in the 90s, to template-based systems in the 2000s, to machine learning in the 2010s. Today we're seeing AI-powered extraction, using AI-based visual and textual recognition for near-human accuracy. Here's a real-world example. A manufacturing company processes thousands of vendor invoices monthly. Previously, the accounts payable team manually keyed in values. Now Apryse extracts vendor names, dates, amounts, and line items as structured JSON, ready for ERP integration. Or a hypothetical retail chain wanted real-time insights from daily reports. Analysts used to manually copy data into spreadsheets. Now Apryse can extract structured tables and values directly into dashboards and BI platforms like Tableau or Power BI. Or another example, support teams often need fast answers from policy documents or operation manuals. Instead of manually searching PDFs, Apryse can extract full text, headings, and metadata, making content searchable and filterable with tooling such as auto-generated FAQs or chatbots. Apryse has brought together the strengths of several leading document tech companies to create a unified, powerful document processing brand. Our SDKs and tools cover everything from doc creation and editing to advanced extraction, all trusted by over 20,000 organizations worldwide. Now, with Apryse Smart Data Extraction, it uses locally run AI models privately trained on real-world documents across industries. These models understand layout, context, and structure without relying on cloud services or third-party data. That means your data stays secure, while our extraction engine delivers high accuracy across paragraphs, tables, form fields, and key value pairing. Outputs are available in structured formats like JSON and Excel, ready for integration into your workflows. Now, one of our most defining features of Apryse Smart Data Extraction is that it is a self-deployed solution. It is platform and language independent with no third-party reliance. You can deploy it in local cloud, bare metal, data center. All your data stays where you want it. This ensures enhanced security and control over your data. Let's switch over to a live demo to show you how smart data extraction works in action. So this is the sample project that we include with the entire SDK that you can download at dev.apryse.com. This is the C++ sample solution, and within it we have various projects that reflect every single API that we have available to develop with, and we are going to take a closer look at the data extraction test uh, project. Now here's the main function of this project, and we have 4 subroutines that each represent the various APIs that we have available in Smart Data Extraction. We'll start with the test tabular data. This function uses the tabular data extraction using the extract data API, and it takes an input PDF and outputs a JSON file. Let's take a look at the input PDF. So here we have the input PDF. It's a scientific report with a table of soils. And the API will turn this into a JSON, basically slicing up this document and intelligently adding data cells in a JSON file. Let's take a look at the JSON. So here's the JSON file that it outputs. You can see we have well-formed table data cells and table rows, and in with them we have data cells. And every cell, an element rather, of the table has well-defined rect objects with their positions on the page specified, as well as the containing data within. So you can see here it's classification, BK, and some text. So this may be a little hard to understand, so let's visualize it by annotating the original PDF. So we've taken the original PDF and added these rectangle annotations based on the JSON file. And you can see where every data cell has been recognized as its own individual element. These external paragraphs or headers have also been added as their own individual tables, whereas this API is more about just slicing up the document into accessible tabular data. As well, this data can be exported as an Excel format, so let's take a look at that. So you can see all that information that was in that original PDF has now been turned into a single spreadsheet. So if you're dealing with very tabular information in a PDF and you needed a quick way to get to that information, you can use this API to slice and dice it up into tabular info. Let's look at some of the other APIs we have available. Now, in addition to tabular data, we also have document structure. Document structure takes an input PDF and outputs a different JSON. Now, this JSON describes the entire PDF in detail, outlining various objects such as paragraphs, graphics, headers and footers, table information as well, images, lines, lists, as well as table of contents if that is part of your document. So let's take a look at this JSON, let's take a look at the original document. Now this input document is a sort of memo page. Attached to it is an invoice. So somewhat rich content, various different types of content available that may be of use when you pull it out. This document will turn into a JSON, which we have here. Now this JSON describes in minute detail everything that was contained in that document. So here we have spans with textual information, with the actual text. Here you can see the text styling available and the original text within the page. Of course, the rectangles, which indicate where on that page that data was found. So this was the first page of that sort of memo information. If we scroll through this, here we can see that we're now in the table on the second page. So here we have a table header, and within it we have, data cells with a unit of or with a data value of unit price, total, and so on and so forth. Lightweight lawn chair, all sorts of stuff. So as you can see with the JSON, if you iterate it with your own JSON parser, you're able to pull out various information from the original document. Let's take a look at what that looks like annotated on the original document for visualization's sake. So here's the original document. All these paragraphs have been annotated in green. This one single bullet list item has been annotated in gray. These headers have been annotated in yellow. These tables that were detected are annotated in red. So you can see all this information was identified and is available as JSON for your own extraction needs. Let's take a look at the next API available to us. We have form field detection. So this one is a little different. We can take an input PDF, such as like a scanned document or a static single flattened PDF, and we have AI algorithms that can detect where on that document there are logical fields for making it, say, an interactive document or transformation into, say, a web page or something like that. So we have an input PDF and output a JSON. Let's take a look at what this input PDF contains. So here we have the original PDF. It's a flattened document of a form. So none of this is interactive or selectable or editable for that matter. Let's see what the JSON it creates looks like. So you can see here, we've detected that there are form fields at various locations and given a confidence interval since it is AI based. That there are text fields with these rectangular coordinate locations on the page. Let's turn this into annotation so that we can better see. Now we have these fields that were identified by AI. You can see that it identified checkmark boxes here in green, and these form fields indicated in blue. Now we also have an API that can directly turn this static document into an interactive PDF. And here you can see this PDF has been converted into an interactive PDF, all through AI recognizing where these fields should be. Now we have one last API for us to look at, and that is our key value extraction. Key value extraction is also an AI-powered API. It takes an input PDF, and again, to JSON, extracts well-paired information that it detects through computer vision. So what we can find are, say, well-paired information in like identification documents or receipts, things like name, John Doe, birth date, January 1st, total, $25, tax, 25 cents, all these sort of well-paired information in a document without ever setting up a template or training it. Let's take a look at this input invoice. So here's the input invoice. We saw this previously in the previous document. Let's see how it looks like turned into a JSON file. So again, using AI, we have confidence intervals that detect that some content here of 291.555.5555 with a key of phone was found. Here we have a date of 4/1/2018, and it's a date. So you can see this is the well-paired information, Harry Styles, Ace DK, shipping, all that was all detected, and it was detected under the to key. So that was an address. Let's annotate this so that we can better see what was found. Now, annotated in red are the keys, blues are the values, and there's a green line that I've added to show the pairing that was found and detected. So here was that date, that phone number, that to address. Here's some tabular information that has been paired up, so you can see that there's various one-to-one relationships, and probably more importantly, we have other key values found such as subtotal, sales tax, shipping and handling, and total due. Now, all that information is available in the JSON. It just requires parsing, and there was no training required. And to reiterate, all this occurs in the SDK no matter where you deploy it. It doesn't depend on an external server or any sort of external dependencies to run this. You just deploy it on your own machine, whether it's cloud or local data source or data server, and all this operation runs locally. Now to summarize, Apryse delivers precision, not promises. Our solution is private by design, AI ready from day one, and it just works out of the box. There are no templates or manual formatting required. Let's open the floor for questions. If you haven't signed up for a free trial, visit dev.apryse.com and get started today.